Hey everyone, my name is Adam, and I will be your speaker today. So today's lecture will be about logic and reasoning. First, we need to define what logic and reasoning is. Logic is a study of reasoning that uses a set of strict rules to determine something's validity, while reasoning is using logic to reach a conclusion. As you can see, logic and reasoning are interconnected in the sense that both are needed to reach a reasonable conclusion. So the process of reasoning is we first come up with a statement, then we use existing rules to determine whether that statement is true, and figure out what the statement really means. For example, let's consider the statement, if I live in Taipei, then I live in Taiwan. What does this mean? Consider the 5 statements below. Which one is the correct one? Can there be more than one correct one? We don't know. So how do we know what a statement really means? We use conditionals. There are 5 things that we need to know about conditionals. First is the conditional itself. Consider P and Q as separate statements. Conditional would say, if P is true, then Q is true. The converse would say, if Q is true, then P is true, which is just the opposite of conditional. The inverse would say, if not P, then not Q, whereas the contrapositive says, if not Q, then not P. The biconditional is special, because the biconditional states that P is true if and only if Q is true. Now, I will go more deeper on the biconditional later on, but first we need to go through the 4 things. Let's just use the example that we had before. The conditional of that statement would say, if I live in Taipei, I live in Taiwan. I live in Taipei is the P, and Q is I live in Taiwan. Is the conditional true? Yes, because Taipei is within Taiwan, meaning that if I live in Taipei, then I must be within Taiwan as well. Now let's look at the converse. If I live in Taiwan, then I live in Taipei. Is this statement true? No, because even though Taipei is in Taiwan, there are other places in Taiwan where you can live. Therefore, if I live in Taiwan, I don't have to live in Taipei. I can live in Kaohsiung, or Hsinchu, or Taichung. All these places are places where we can live without being in Taipei. So this is false. The inverse is, if I do not live in Taipei, then I do not live in Taiwan. Is this statement true? This is definitely not true, because if I do not live in Taipei, I can live in other places in Taipei and still live in Taiwan. Therefore, the inverse is not true. As for the contrapositive, which states that if I do not live in Taiwan, then I do not live in Taipei. This is not true since Wait, what?
Do you ever look at someone and wonder what is going on inside their head?
This has to be true because not living in Taiwan means that you cannot live in any of its cities. Also notice how when the conditional is true, the contrapositive is true. And when the converse is true, the inverse is true. When the converse is false, the inverse is also false. Notice how when the conditional is true, the contrapositive is true. And when the converse is true, the inverse is true, and vice versa. This is because the converse and inverse are opposites of each other, and the conditional and contrapositives are also opposites of each other. Therefore, by using conditionals, we can determine which statements are true about the original statement, if I live in Taipei, I live in Taiwan. Now, let's dive deeper into a biconditional. Consider the following statement. If a triangle has a 90-degree angle, then it is a right triangle. Is this statement true? I'd say so, because a 90-degree angle is a right angle, and all triangles with a right angle are a right triangle. For the converse, it reads, if a triangle is a right triangle, then it has a 90-degree angle. Is this true? Yes, because all triangles that have a 90-degree angle must be a right triangle. Therefore, if a triangle is right, then it must have a right angle, which is literally in the name of right triangle. For the inverse, if a triangle does not have a 90-degree angle, it is not a right triangle. Is this true? Yes, because by definition, all right triangles must have a 90-degree angle. Therefore, if it contains other angles, then it does not qualify to be a right triangle. As for the contrapositive, which reads, if a triangle does not have a 90-degree angle, then it is not a right triangle. This statement is also true, because a triangle that does not have a 90-degree angle does not qualify for being a right triangle, because all right triangles must have a 90-degree angle. Now, let's move on to the biconditional of this statement. If you remember from the previous slides, biconditional is P if and only if Q. Notice how the arrow goes both ways in the biconditional, which means that P then Q and Q then P both must be true. Therefore, when the conditional and the converse are both true, it can be inferred that the biconditional is also true. So let's read out the biconditional. A triangle has a 90-degree angle if and only if it is a right triangle. Is the statement true? You get 10 seconds to think about this. This statement is true. There are two ways that you can figure this out. The first way is easy. Since the conditional and the converse are both true, then it must go both ways, and therefore the biconditional must be true. But if you think about it logically, a right triangle has to have a 90-degree angle, meaning that if a triangle is right, then it must have a 90-degree angle. But what about the only if portion? Is it true that a triangle has a 90-degree angle only if it is a right triangle? Yes, because if a triangle has a 90-degree angle, the only triangle that qualifies for a right angle is a right triangle. So after dealing with conditionals, we will be moving on to Demorgans laws, which is another set of rules that determine whether something is true. Demorgans law is used in a variety of different places, especially in coding and other algebraic functions. It reads, not A and B is equal to not A or not B, and not A or B is equal to not A and not B. And you can look at the algebraic form below. The U stands for union, while the N stands for intersection. Remember that A and B are both statements with a true or false value. Remember that A and B are both statements with a true or false value. So it's saying that if A and B are both true, then not true is equal to false. Therefore, false is equal to not A or not B. Since A and B are both true, not A would be false, and not B would also be false. And false or false is equal to false, because in order for the whole statement to be true, at least one must be true. In a more realistic example, if I say that I can have an apple or an orange. If I don't have an orange but I have an apple, then it is true that I will get what I want, right? If I have both, then it's also true that I will get what I want. The only scenario where I do not have what I want is if I don't have an orange and I don't have an apple. So consider A as apple and B as orange. It is the same for the second part. If I say that I have apples but not oranges, only one of them has to be true for me to get what I want. Therefore, true or false is equal to true, and not true is equal to false. So the left side of the statement is false. And therefore, false is equal to not true and not false. Not true is false, and not false is true. So this is different because and implies that both have to be true, right? If I say that I want both an apple and an orange, then I must have both. If I don't have one of them, then I don't get what I want because I want both oranges and apples. Therefore, true and false returns a value false because both have to be true for the whole statement to be true. Now let's do some practice on Demorgans law. First, let's define some variables. Consider x, y, and z to be three different statements. The statement x is false, the statement y is true, and the statement z is equal to true. Find the value of not x and y, or x or not z. You have 30 seconds to answer this. Okay, so this is a bit of a confusing one. Let's examine this closely, right? If x is false and y is true, then x and y returns false. Remember to use Demorgans law. Even though you don't have to, Demorgans law is a good way of analyzing these statements. So not x and y, remember, is equal to not x or not y. Since x is false, not x is equal to true. And since y is true, not y will be equal to false. So since it's false or true, then the whole first part of the statement is true. After figuring out the simplification of the first part of the equation, we plug it into the second. So since the first part returns true, let's look at the second part. X or not Z. Remember that Z is true, therefore not Z will be equal to false. And since X is false, both would be false. Therefore, it becomes true or false. Therefore, while the first part evaluates to true, the second part evaluates to false. But since in the middle it's an or, meaning only one of them has to be true, since one of them is true, then that means the whole statement is true. Therefore, we can see that this statement is true. Thank you for watching today's lecture, and we hope to see you in future videos. Stay tuned for part 2.